Hello everybody, and welcome to the lemma on page 55 of the workbook. And in this video, we are going to focus just on the proof of part 2 of this lemma. Okay, so let's read that statement again together. It tells us that the coset A times H is equal to H if and only if the element A that we started with is in the subgroup H. Okay, let's see if we can prove that statement. Okay, notice that the statement is an if and only if, and so we're going to have two directions to this proof. We'll start with the forward direction. So in the forward direction, we would be assuming that the coset A times H is equal to H. Okay, and see if we can prove that as a result of that assumption, A is in H. All right, so we'll start just with the observation that since H is a subgroup, we know that it contains the identity element. Okay, and if E is in H, then by definition, that means that A times E is in A times H. Okay, but if you think about what that's saying, that means that A, which can be written as A times E, okay, is in A times H. That's the observation that we made above, and our assumption was that A times H is H. And if you look at that statement, we have proven that this element A lives in H. Okay, that's the forward direction of the result that we wanted to prove. All right, so we've proved the forward direction. Let's look at the reverse direction. Okay, what would our assumption be in the reverse direction? Well, here we would be assuming that A is in H, and trying to prove then that the coset A times H equals H. Okay, so if we want to prove this statement that I'm underlying up here, notice that that's a set equality. We want to prove that the set A times H is equal to the set H. How do you prove that two sets are equal? Okay, kind of the standard way is to show that one set is a subset of the other and then to turn it around and show that the containment also goes the other way. Okay, and it turns out that AH being a subset of H, that is sort of the easy direction. And here's the claim that I'm going to make. Let me just write this sentence and we can say a few words about it. I claim that by closure, we know that the coset AH has to be a subset of H. What do we mean by that? Okay, well, this A that we're starting with comes from our subgroup H. That was our assumption here. And so if that A lives in H, what happens when you take something that's in H and multiply it through by everything that's in H? Okay, well, H is a subgroup, which means that it's closed under multiplication. Okay, so if you take something like A that's already in the subgroup and multiply it by something else that's in the subgroup, it has to stay in the subgroup. And that's what we're saying when we say that it's a subset of H. Okay, so there's not a whole lot to do to prove that containment. Okay, to finish our proof, we just need to show that we get containment in the other direction. Okay, so we still want to show that H is a subset of AH. Let me put that on the next line. H is a subset of AH. We can show that. We are done with the proof of the reverse direction here. Okay, and to prove this direction, we're going to use standard pick a point. So we'll start by choosing something that's in H. Okay, see if we can show that that X also lives in A times H. Okay, so to do this, let's remind ourselves what our starting assumption was, that A is in H. Just kind of see where that assumption leads us. Okay, so since A is in H, and we know that H is a subgroup, we also know that the inverse of A must be in H. Okay, and that means that A inverse times X is in H. Now, where does that come from? Okay, well, that's basically closure again. So we know that A inverse is in H, and we assume that X is in H, so if you take the product of A inverse times X, that's got to stay in H, okay, by closure. And then we just make the observation that if A inverse times X is in H, then A times A inverse times X has to be an A times H, just by the definition of what that set A times H looks like. Okay, but we can do a little simplifying here. What happens if you take A and multiply it by A inverse? You get the identity. And the identity times X is just X. Okay, so take a look at where we started and where we ended here. We picked a point in H. We demonstrated that that point is also in AH. We have just shown that H is a subset of AH. Okay, and that completes the proof because we already showed up here the other containment. Okay, and so we are done with number 2.